Hi, and welcome everyone to this Keptn webinar on evaluating the resiliency of your microservices with Litmus Chaos tests and Keptn. I have a very special guest today. Hi, Kartik.
Hello, everyone.
Kartik is a maintainer and architect of Litmus Chaos, and he will join us for this webinar and give us more background information and all the details on Litmus Chaos. And we have also prepared a demo that we will show you how you can actually use Litmus Chaos and how you can use the integration that we've built together. We have a chat feature and a Q&A feature in this Zoom webinar, so please make use of these features if you want to ask any questions. We will be actively taking a look at the chat and the Q&A feature, so we will try to ask these questions. I'll try to forward the questions to Kartik, or we will just answer these questions during the webinar or at latest at the end of the webinar, where we also reserve some time for the Q&A. But let's just jump into this webinar and explain a little bit what we actually want to do. So we will talk a little bit about how to actually evaluate the resiliency of microservices and how you can do this with Litmus Chaos. We will talk about also how and why functional tests are not enough. Because outages might happen or will happen in your production environments, and chaos engineering is a way to already, let's say, simulate these outages or actually trigger these outages and then react on this. And with chaos engineering and Keptn, we can actually evaluate then the resiliency of your microservices with the SLO-based evaluations of the Keptn quality gates that you might already know. If you're not so much familiar with either Litmus Chaos or Keptn, don't worry. We will cover everything in this webinar, and at the end or in the second part of the webinar, we also have a demo, and we will come back after the demo for a Q&A session. So stay tuned. We are really excited to share all this content with you. And Kartik, I will share also my screen here with you so that you can progress with the slides, and I hand over to you.
Thanks, Jürgen. Thanks for the intro and setting the agenda for this webinar. Let me go to the next slide. All right. We talked about evaluating the resiliency of microservices. So I'm sure all of you have either migrated to Kubernetes to deploy your applications, or you might be in the process of doing so, because Kubernetes is now become the de facto way of de facto platform for deployment of microservices. It's also a popular development platform today. So it's both a development platform as well as the eventual deployment platform on which your application is going to run. So during the course of time, during this migration, you might have made a lot of changes to your application. You might have re-architected it. You might have made it more distributed. You might have made it containerized. You have made it loosely coupled. Now you're ready to get onto Kubernetes. But there's a lot of apprehension because Kubernetes is a really complex and dense system. And whenever you're running your applications on top of Kubernetes, it essentially means that you have a lot of layers playing at one point of time. You have the platform services or the infrastructure upon which you've created your cluster. It could be on-premise or it could be on the cloud. Then you have the actual Kubernetes components, the various services, the control plane of Kubernetes, along with etcd and all the services. And most often, you're not going to deploy your application in isolation. It's going to be working along with a lot of other tooling that you might have sourced from the CNCF landscape. You might be using monitoring components like Prometheus, Grafana. You might be using service discovery mechanisms. You might be using stateful storage providers. You might be using container-based storage solutions like OpenEBS. And you have so many of these. And then to run your application, you have dependent framework components like MongoDB, or you might be running message queues like Kafka. You might be running Postgres. there will be so many other stateful components and stateless components that make up the framework. We've still not hit the business app yet. And then comes your actual application. Your application, you might be running it as a set of microservices. You might be running one or more replicas of this application. So you can see that there are so many layers that's there on your deployment platform. And in production, there's going to be a lot of data, a lot of complex operations that's going on this environment. There can be failures at any of these layers. And that's why we are saying in this slide that more than 90%, figuratively speaking, the resiliency of your application depends upon other components, most of them cloud native, and your physical infrastructure on top of which you're running that. And outages cost a lot of money. We've heard of famous incidents on Slack or GitHub or AWS, where you lose just a lot of money by being down for just a brief period of time. So when you're migrating to Kubernetes, you're really interested in verifying if your application is going to take these failures and still be operational. And when we say operational, there can be a lot of meanings to it. We talk about the 5 9 6 time kind of availability. Availability is one facet of your operational metrics, of your operational excellence. There will be other things, how quickly you recover from a failure, for example. These are all some things you want to measure beforehand. So that's where chaos engineering comes in. Chaos engineering is something that has been popularized and it's really become important over the last 10-11 years, especially from the time there has been a distributed microservices-based architecture of deploying applications. Netflix coined the term chaos engineering really, but it has been practiced in some form or the other by a lot of organizations since. And there's a subtle difference between testing and chaos experimentation. You could argue that failure testing is very similar to chaos, injecting failures, but chaos engineering is not only about injecting failures. It's a mode of experimentation. And there's always this hypothesis that is attached to your chaos engineering. In failure testing, most of the time, the focus is on the how. That is how the application is going to function. And you're really interested in finding out the nuts and bolts of your application as to how it is performing. But with chaos engineering, you're mostly interested in the what. When your application is deployed in production, there are some metrics that you're going to track, saying this application is working the way it is supposed to. This is what we call as SLO, service level objectives, and service level objectives might be defined in different ways. It could be defined by metrics, Prometheus metrics. There's always some kind of metrics associated with it. These are called service level indicators. And there could be other indicators. There could be a certain state of a particular resource on Kubernetes, and that's very popular nowadays because of all this, the operator concept that's coming in. Application intent is being expressed in custom resources, and the state of these custom resources generally indicates how your application is performing or what state it is in. So you might have a lot of different kind of ways to identify the way your application is performing or your infrastructure is performing, whether you're meeting your SLOs or no. So that's where chaos engineering really comes in. It tries to execute some failures, inject some failures, but at the same time, you're also going to, as part of that, evaluate what's happening to your SLOs. Even if you were missing the mark, how quickly you've recovered. That's where all these metrics, like the mean time to failure, mean time to recovery, mean time between failures, etc., come in. So chaos engineering is a lot about resiliency in all these aspects. It is much like vaccination. It's about injecting failures beforehand in an environment that's going to mimic your production environment to see how things are going to work. And oftentimes, chaos engineering is performed as game days where you have a lot of folks working on the product come together, different stakeholders come together, and you take a sign off from each of them, set expectations beforehand, have mitigation plans or rollback after you inject chaos. If things are not going according to the way you perceive them it would go, then you can roll back and get system to an optimal state. So these are the things that you typically carry out as part of chaos experimentation. And when it comes to Kubernetes, cloud native more or less implies Kubernetes native in today's world. And when it comes to Kubernetes, the user experience of a developer or an SRE or a DevOps engineer on Kubernetes is all about YAML. It's about dealing with different kind of resources, native resources, custom resources. Everything is declarative. These configurations are maintained in your Git source. The infrastructure is available as code. So you bring up your clusters using some infrastructure as code modules. You could be using Terraform, you could be using Ansible, or you could be using anything like that. And then the applications that you're running on top of Kubernetes is also stored as YAMLs. You could be running them as deployments or stateful sets, whatnot. So that's where all the GitOps comes in. All the GitOps controllers or deployment managers, as they are called popularly, ensure that the state of your cluster is what is reflected in the state of your source, your Git source. So when dealing with different aspects of Kubernetes, you could talk about infrastructure, you could talk about application lifecycle management, resource management, everything is policy management, everything is controlled via YAML in a declarative fashion. So when it comes to resiliency tests or experimentation, you also want to adopt the same kind of an approach to doing this as well. So that's where Litmus comes in. And Litmus was born as a project. It was born out of the need, the chaos engineering needs of the containerized storage project OpenEBS, which is also a sandbox project in CNCF today. And as a community, we figured out that a lot of folks that are running OpenEBS needed a Kubernetes native way to run experiments as well. And that's when we thought, okay, we should have the same user experience. You can see that in Kubernetes nowadays, everything is reconciled. You have resources that and the corresponding controllers, and the controllers do the reconciliation operation. And we wanted to enhance, or we wanted to take the chaos engineering toolset or systems available at that point of time. We wanted to make it cloud native and define a subcategory called as cloud native chaos engineering. And cloud native chaos engineering typically does this. We identify the steady state conditions and we introduce a fault and we check whether the steady state conditions are maintained or whether they're regained within a desired period of time. If so, then we're calling that infrastructure or application or your deployment environment as a whole resilient to that scenario or that outage or that fault. If not, then that means there's a weakness found and you go back to your drawing boards and you fix either the business logic of the applications or you go and set something right in your infrastructure or your deployment patterns. So with Litmus, we try to map this traditional chaos engineering flow into CRs. So we have the chaos experiment CRs, which are defining your faults, the chaos engine CRs, which are binding an application instance or binding a particular infrastructure instance like nodes or deployments to the experiment. And there's an operator that's reconciling the state of the chaos engine. It acts upon the CRUD operations that you perform to the chaos engine, runs the experiment using the help of a certain number of chaos resources pods. We are representing them by the chaos runners. And then it generates a result depending upon whether your steady state checks were met or no, whether your hypothesis was achieved or met or no. So just to look at these chaos CRDs once again, these are the heart or the crux of the Litmus Chaos project. The chaos experiment CR is basically a granular definition, a low-level chaos intent. It specifies things like image. What are the images that are necessary to run your experiment? So the experiment run as Kubernetes jobs. The experiments themselves, the fault injection methods are themselves containerized. And this is where Litmus has this approach of bring your own chaos, BYOC. That is, you might be doing some kind of failure testing already, and you might wish to do that in production to see how things behave. Litmus helps you to orchestrate those tests also. It gives it an experiment paradigm. And it orchestrates that and helps you to find out whether your hypothesis is being met. And it's going to give you those results. So the chaos experiment is going to contain information about the experiment itself, the fault, and also the necessary permissions to execute that particular experiment on your cluster. So different experiments have different blast radius and thereby a different set of permissions associated with them. So the Chaos experiment defines that, and it's pre-built and available on the Chaos Hub, which is an open hub. You can call it as some kind of a marketplace for Chaos experiments, which is open and free. And you can pull your Chaos experiment CRs, manifest, and install them on your cluster. So they are pre-built. The Chaos engine is another resource, which is actually binding your application instance or your infrastructure instance component with a particular fault, and also provides run characteristics. You want monitoring turned on or turned off. Where do you want the Chaos resources to run? Sometimes folks designate nodes to run utilities like Litmus. They want all the control plane of Litmus to run there, whereas you want other microservices of the application to run elsewhere on the other nodes. So you can define the scheduling policies where you want the Chaos resources to run. You can define your steady state, defined as the state of a certain downstream service endpoint, whether it's accessible or no. You can look at this, the state of a Kubernetes resource, or any such methods can be specified in the Chaos engine. You can declaratively define your hypothesis using something called it as probes. And this is the engine that's user-defined and is reconciled by the Chaos operator. Chaos schedule is another CR that helps to repeat your chaos in different ways. You can execute it once at a particular time or run it across time ranges with a specific interval. You can do it randomly, or you can strictly schedule your chaos, etc. And result is another CR which is generated at runtime by the experiment itself. And it holds information about the experiment state, what is the verdict, what is the probe status, and any failure steps if at all there has been an experiment failure. So these are the important artifacts in Litmus that you would be dealing with on a day-to-day basis. Now, just a schematic diagram to tell what happens with Litmus during runtime. So we have a cluster in which you install the Litmus infrastructure components via Helm or via manifest, which installs the operator and some associated deployments like the event and metric exporters. And we have installed the Chaos CRDs as well. Then we pull the Chaos experiment CRs from the hub. We create the Chaos engine, which then is watched by the operator, and it in turn creates the Chaos runner pods, which are the ones that actually execute the Chaos jobs. And the results are stored in a Chaos result, which is available for consumption, and you can create your decisions based upon this result. So this is what happens with runtime. Now, I just want to take a moment to introduce you to the Chaos Hub. We dwelt upon this a couple of minutes ago. This is the hub.litmuschaos.io website, where you can find experiments of different categories. The generic category is the one that has a lot of Chaos experiments for Kubernetes, killing pods, doing resource stress, injecting network chaos, etc. And then there are some application-specific experiments that are about injecting these failures, these faults, but with an application context. You give an application spin to the experiment. So for example, in the Kafka experiments, you would be looking at whether your consumer message timers are adhered to when some of the brokers are killed, for example, things like that. And similar with Cassandra, is the ring reformed and redistribution occurred successfully, things like that. So you are free to pull experiments from the hub and use them, and also contribute things back to the hub and earn some open source karma along the way. Now, one of the things about chaos engineering that's been happening in the recent times is the fact that there's been a left shift, and people are using chaos even earlier than in production. Chaos engineering is ideally done in production, but a lot of folks are not ready for that. People do it on pre-prod or staging environments that mimic the production. But now the developers are getting involved in doing chaos much earlier. They're doing it in the CI/CD pipelines. And that's because of this principle of chaos. You can see the code, automate experiments to run continuously. So people are running experiments during their CI. And most importantly, they're also integrating it. They're also planning to run chaos experiments as part of their release pipelines. So they bring it into the continuous delivery process, not something that's left to the SRE ops. So people do some kind of chaos experiments in CI pipelines on ephemeral target clusters, then go ahead and use the images or application artifacts that are qualified in long-running clusters. They then bring it onto staging, pre-prod, and then eventually deploy the application in production and then do chaos there as part of a game day. So this is the left shift that's happened in recent times. And one of the important facets or requirements of being able to run chaos as part of your continuous delivery pipeline is to be able to validate your SLOs as the experiments run. That's where we are integrating with Keptn, and the integration will allow you to validate what happens to your infrastructure and your application, whether your SLOs are being met as the real world load happens on the application and chaos also happens in the background. So that's a brief intro about Litmus and chaos engineering in general and where we are headed. Thanks, Jürgen. I think it's over to you now.
Well, thank you. So I'm taking over here. Let me quickly introduce how we are doing chaos engineering in Keptn, or not doing chaos engineering in Keptn, but how we built this integration. And Kartik already mentioned that we will bring it into the CD pipeline and really have it as part of CD and not only have it once you're running in production. As a quick recap, what is Keptn and why can we do it easily in Keptn? Being a control plane for cloud native delivery and operations, it allows to integrate new services or new integrations quite easily because Keptn is event-based. So basically what we need to do for integrating with other tools is to send events to these tools or to receive events. For this use case, we have really focused on the SLO-driven multi-stage delivery. Keptn has more capabilities, but we really focus on this one. You might first think about doing operations and remediation with chaos engineering to really introduce some chaos in your environment and then having some kind of remediation scenarios tackling this chaos. That's actually a very good idea and a very good approach. This will be something that we are also already thinking about. But for the first use case, we've really thought, how can we introduce chaos as part of the CD pipeline triggered by Keptn and then also evaluated by Keptn. Oh, it was too much. So here we go. So how is this integration be done? The conceptual architecture of Keptn is here explained in a way that we have the Keptn control plane living in your Kubernetes cluster, and you have a couple of different services connecting to this control plane. So there are a couple of services that are already built in by Keptn, but there are also services that you can just add later on. Some of them, they come as, let's say, batteries included, and some of those, they come, you can just install them. And we have services for having a Git repository. Keptn comes with its own Git repository that lives in your cluster, but you can back it to a public or to a cloud-based Git repository. You can link your container registry. You can link different deployment tools, test automation tools like JMeter, and that's also where we see the Litmus integration. You can link tools for ChatOps to either get notified by Keptn directly in Slack or from Slack to control Keptn. And you can have all these different services that you connect to Keptn. And based on this, Keptn can then send the cloud events and receive cloud events from the services. And with this, it can really orchestrate all these different tools. So we've prepared also a demo for today. And I will briefly explain what we will see in the demo, and then Kartik will explain our demo environment, and then we will jump into the demo. So let's imagine you have a pipeline. We want to deploy something into our chaos stage. We are using in the demo a new CNCF demo project. It's called Potato Head, and we are deploying this using Helm. So we are deploying this. As a next step, once the deployment is finished, Keptn will go ahead automatically and trigger the tests. In our case, we will trigger some load testing with JMeter but also at the same time, we are triggering Litmus chaos experiments. So this is the benefit also from Keptn, that being event-based, we can trigger different integrations at the same time, since they just listen for these events that they want to start the tests. So both JMeter tests and Litmus Chaos will be executed on our demo application. Once the tests are finished, Keptn will be informed that the tests are finished and will trigger the quality gate. The quality gate basically reaches out to a data provider. In our demo, it's Prometheus. And from the data provider, it will query the SLAs and evaluate the SLOs, and will then come up with a score. And based on this score, you will get, let's say, a thumbs up, you will get a high score, you will pass the quality gate. That also means the resiliency that we are checking in our SLOs is satisfying, or if we cannot reach the score that's needed, that means our resiliency is not satisfying and we need to rework, or we have to work on increasing the resiliency. I think, actually, I was not sure if I do have an example of the Keptn quality gates, if I have a slide here, but if not, it's not a big of a deal, because I will just explain this then in the demo. So Kartik, you can go ahead and explain the demo environment, and then we'll jump into the demo.
Sure. Thanks, Jürgen. I think like you're seeing on screen, the demo environment is running on a GKE cluster. It's a multi-node GKE cluster. And we have a sample application. This is from the CNCF called the Potato app. And this is essentially a Hello World service that's running on the cluster. We are running it in the Litmus Chaos namespace, and its deployment is being controlled by the Keptn control plane. As part of a deploy event, we are going to have the Potato Head Hello Service app deployed on the cluster. And we also are going to launch the chaos experiments. The pod delete chaos experiment is going to be performed. You can see on the box here that we're going to do a graceful pod delete. We're going to kill one replica randomly. We're going to iterate just once, so we're just going to do a kill once. And this experiment needs the operator to be installed and the CRDs to be installed already, which we have done in this cluster. You can find the instructions in the Litmus service repository in the Keptn sandbox, or which Jürgen is going to point out shortly. So we have the Litmus infra components already available. The experiments are going to be triggered immediately after the deployment of the Hello service is successful. And we also have a Prometheus installation here that's being managed by the Keptn control plane, which is being aided by a black box exporter. The black box exporter is basically trying to collect information, availability information of the Hello service app, and it exports two metrics regarding this. There's a probe success percentage, which is essentially about how much times it is successfully able to query the Hello service, and we are representing that as a percentage. And another one, which is the duration in microseconds, the amount of time taken to receive a success upon trying to access the Hello service. These metrics are being scraped by the Prometheus instance, and there's a Prometheus SLI provider also managed by the Keptn control plane, which is going to run some average functions against the data in the Prometheus TSDB to find out what's been the average probe success percentage and probe duration seconds value across the period when the JMeter tests and chaos tests run in parallel. So this is what we have in terms of the demo environment. I think now we can go ahead with the demo.
Perfect. So I'm taking over here a screen. Yeah, thanks for explaining the environment. And let's just take a look at what we currently have. Currently, we have, that's the Keptn's UI. We call it the Keptn's Bridge. And we currently have an application running. It's our Hello service. And we just deployed in one stage. So it's, in this case, it's not a multi-stage deployment, it's just a single stage deployment, because we are interested in evaluating the resiliency. So we want to deploy it in this environment and have Keptn and trigger all these automations, like executing the tests, introducing the chaos, evaluating the tests and the chaos, and then coming up with a score. So starting with this, you might actually start with a pipeline that you already have, either inside Keptn or not inside Keptn. If you do it in Keptn, then it's easy to introduce the chaos service or the Litmus service easily for all of your pipelines by just adding this one integration. So there is no need to rewrite hundreds of pipelines if you have hundreds of microservices, but it's just you just define one additional service, and the service will listen for events that are sent through the delivery of the artifact. And so that's really easy to include this. We've already prepared this, and we will go ahead and start a new deployment. So what we'll do is we will deploy my demo application, or it's actually not my demo application, but I hosted it here under my GitHub account. But we are taking the official CNCF Potato Head application, and we've made only some introductions with Prometheus instrumentation. This is the reason why we pushed it into our private GitHub Docker Hub account, and we just want to deploy it with a replica count of 1, and we will go ahead and we will do this with the Keptn control plane and with the Keptn CLI. So in this case, I'm just sending this cloud event via Keptn to my Keptn control plane, and Keptn will take over and will take some action based on this cloud event. So this cloud event is of the type configuration change. So Keptn now knows there is some configuration change, and will figure out it's this version of the microservice with a replica count of 1. That's our basically that's the basic configuration. And we can take a look in our Keptn's bridge. So we can see there was a configuration change just received. We can also see the deployment was already finished. And once the deployment is finished, what Keptn does is it will trigger the tests. And in this case, it's not only the JMeter tests, but it's also the chaos tests. And we can actually take a look in our lens. That's an IDE for Kubernetes, let's say, and we can take a look. I just reloaded, and we can take a look that there is a couple of things going on. So we can see there is a chaos runner, there is a pod delete pod, and there's also the hello service. It was actually, when I was reloading, we can see it's not yet up there, and we can see it's very new. So the initial deployment was already finished earlier, but the chaos experiment was already triggering a deletion of our pod. So we just wait for the pod to come up again. It will take a couple of more seconds, and we can see it here. So the pod was coming up again, and I think I'm fighting with the mouse against Kartik here. So we can see it's up and running again. So what we will do is we will come back to the Keptn's bridge, and we'll take a look if the tests have already been finished and what is the evaluation of the tests, and if we have a high resiliency of our microservice or not. Just checking up here, the tests have not been finished. So what is going on in the background? Keptn was triggering both testing integrations, let's say the JMeter service and Litmus Chaos. The Litmus Chaos was finished a little bit earlier than the JMeter service, and what we are really waiting for here is for the JMeter service to finish. And we can already see JMeter tests have now been finished. Keptn is automatically trying to retrieve the SLAs. These are the service level indicators that will provide us with the data that we can then use in the evaluation. So Keptn reaches out to, in this case, it's Prometheus, will fetch the data and will come up with a score. So we have an evaluation that was executed, and we can see our result was actually 0%, and we will need at least 75% for it to pass. So what is the actual problem? We can see the probe success percentage is too low, it's only 73%, and our probe duration is too high. It should stay with slower than 100 milliseconds, and the percentage should be higher than 90 or 95%. So we see the resiliency was not high enough. Actually, we failed this evaluation. What we will try now in the second run of the demo, we will try to increase the replica count. Keptn will automatically trigger the tests again, the chaos again, and will come up with a new evaluation. And we will check if the new evaluation will successfully pass our criteria regarding the resiliency. So let me go back to Visual Studio. I will just increase the replica count here. We take the same version, the exact same application, and I will just send another cloud event to Keptn. Again, Keptn will take over. We will just take a look in the bridge when Keptn is picking up this event. It should just take a second. So Keptn is already picking up this event, and now we will switch back to Lens. Why I'm doing this so quickly is because right now we can see that there are 2 additional instances of the Hello service coming up. This is, we increase the replica count. We can see now there are 2 additional services coming up. So we will see just in a second that there's also an event sent to Keptn, that the deployment is finished. Usually takes about 30 seconds for it to be ready. We introduced a readiness probe, and we just wait for a couple of seconds for it to be ready. Now the deployment is ready, and we are already triggering again the chaos tests and the GMeter tests. And we can see that this integration is was creating the chaos runner, and the chaos runner in turn is creating our pod delete. This again will take a couple of seconds before it starts to act. And acting in this case means it will delete one random pod of the Hello service. Kartik is then also going to explain what is going on a little bit in the background. Do you want to jump in right here, or should we wait for the experiment to finish and then take a look what's also going on in the background?
Yeah, I think we can sort of look at the events. So you can see that the Keptn control plane is actually launched. Custom resources, the chaos engine has been created, which has led to the creation of these pods, the runner pods and the pod delete pod. I think on the lenses, we have a category for custom resources here that you can take a look. And we have the LitmusChaos custom resources here. You can see that the chaos engine has been created. This is the Hello Service Chaos, which was launched, that led to the creation of the experiment. And this is some basic information about that custom resource. But interestingly, I would like to show you what happens over the course of the experiment. You can see that there are a lot of events generated when the chaos engine has been in operation. And these events are helpful for observability purposes and to know what's actually happening as the experiment goes about performing its thing. At each stage of the experiment, you have an event that's signifying what went well or no. You can see that the chaos resources have been created successfully. There's some validation that happens against the chaos resources. Sometimes some experiments have dependencies like config maps or secrets that you might push. So as part of the experiment run, the operator validates whether they are available. Then we create the experiment job. Then we check as part of a pre-chaos entry check whether the application under test is running. After the chaos is completed, we go ahead and check once again for the application as part of a post-chaos and an exit check. Then we go ahead and remove these resources. So this is what happens. I just wanted to show this, what happens in the background when the resources are applied. Yeah, I think we can now take a look at our Keptn bridge.
Okay, yeah, thanks for sharing these insights. So let's take a look. All the pods are running. We have 3 instances of our Hello service running. So that's actually our, again, our desired state. Let us take a look in the bridge, what was actually going on. So we can see there was another test run. The tests have been finished, and we can see another evaluation. This time the evaluation is green. Both of our SLOs are evaluated positive. That means we got full score on this, and we can see the probe success percentage is now 100%, and our probe duration in milliseconds is now lower than 100 that we set as a boundary. So why it is 100% now? Because we have 3 instances running of our JMeter, of our Hello service, and if we kill only one of them, we still have 2 of them as a, let's call it a backup. So the traffic can be served by either the 2nd or the 3rd instance. In the previous run, the traffic could not be served. So we got from the black box exporter, we could not successfully do our probes. And this was the reason in the first run, we got not a very high success percentage, because for a couple of requests, the service was not ready to respond. With a higher replica set, we can now satisfy our quality criteria. So with this integration between Keptn and LitmusChaos, it's very easy to evaluate the resiliency of microservices, because you can just play with the values, for example, of a replica set, but you can also tweak other things. You can write your own SLIs and SLOs, and you can then just run a new delivery workflow with Keptn and have chaos engineering and also some performance tests being executed, and you have an automated evaluation of this test run. So you can automate a lot of things, and you can even think of building a multi-stage pipeline with this. So every time that you successfully pass a quality gate, you can move it to the next stage, for example, to a pre-production stage, or from a development stage to a chaos stage, to a pre-production stage, to a production stage. So all of this is possible with a lot of automation and with the help of LitmusChaos and Keptn. We already had a couple of questions in the chat. I would just take a look at them. I know Kartik is already answering them. I'm not sure if everyone can see the questions and the answers. So the last question, which is really much related to this scenario, is why are we triggering load with both Litmus and JMeter? It's a very good question. The reason is, when we only execute the LitmusChaos on our service under test, we don't have a lot of traffic on it. So it's difficult to make good evaluations in the quality gate if there is no traffic on the service. So for this reason, we are executing both the performance test, but also chaos, because we want to actually identify how does chaos affect our application if it's under load. Because in production, you hopefully always have some load on your system. For this, we want to evaluate LitmusChaos experiments with some load testing. It doesn't have to be JMeter. You can use NeoLoad, you can use BlazeMeter, you can use other tools. But we think it's a good practice to have load on and chaos at the same time, because otherwise it would just kill a pod. And if it doesn't receive any traffic, you would not get any valuable insights into the quality.
Just to add on to that. Thanks, Jürgen. I think just to add on to that, I think Deepak had an interesting perspective about considering load as chaos. That's a very nice perspective, and there are ways of triggering load via Litmus as well. I saw the question on chat. There are experiments which help you to trigger IO stress on your applications. You can even do CPU hog and memory hog, disk fill kind of experiments using Litmus, and you could even do some kind of continuous checks against your app. If you're talking about some kind of a HTTP GET call continuously against your application, that's something that's doable. Some experiments do it already, but like Jürgen said, we are trying to combine JMeter along with an injection, fault injection in this case, because we are trying to simulate a production-like scenario, with some real-world scenario where your applications are receiving traffic from some downstream service or end service, which is when the outage might happen. There were some questions that were already asked in the Q&A section of Zoom. Some great questions there as well. I think one that's really interesting is how do you see setting SLOs for critical path versus non-critical path? So I tried to answer that by saying Keptn allows you a graded kind of SLO. So you saw right now in the bridge that you have a certain percentage below which you're going to be called as failure, after which you'll be warned, and then you'll actually fail. So it's basically, or it's a success. So it's a success, there's a warning, and then there's a failure. And you can set these SLOs against different SLIs that you might have configured. So you might have metrics that you are creating SLI against. You might have a list of them instead of just one. In this case, we have a couple of them, probe success percentage and probe duration milliseconds, but you could have more. And those metrics can actually be indicative of the critical path or non-critical path, and you can set these gradations, you can adjust these warning, failure, and success against them in order to get that overall experience of, this is what my SLO is for a non-critical service, and this is what it is for a critical service. That's just my perspective. I'd like to hear from Jürgen as well.
Yeah, exactly. Thanks. It was a perfect answer already. But I just wanted to point out, we also have this here in the UI. We have a pass, a warning, and a fail. We also, if you just want to be notified about something, you don't have to define any qualitative criteria. You don't have to define an SLO for the SLI. You can just include it if you just want to retrieve the values. So Keptn is anyway reaching out to the data provider and capturing all the values. If you just wanted to have it listed here, this can also be done. So, and you can even weight the different SLOs. So you can say this SLO is very crucial for me, so you can give it a higher weight than other SLOs. You can even define it as a key SLO. So every time a key SLO is failing, that means the complete quality gate will be failing. For example, something like uptime or error rate. You would not want a higher error rate of, let's say, 5%, 10%, or whatever is crucial for you. But if you have a lot of SLOs defined, you might also want to say, and it's that critical that you want to define it as a key SLI. If it fails, then you would not count it with the same percentage of priority into the complete quality gate evaluation, but you just want to fail if this is failed. And I have other projects here that have different kinds of SLOs. It's just that in this demo, Kartik and I, we decided that we use the probe success percentage and the probe duration in milliseconds. What you usually get out of the box when you're using Keptn is the red metrics. It's the error rate, the throughput, and the response time. These metrics you will get out of the box for services, for microservices or applications that you manage with Keptn. And these come out of the box, and then you can create your own SLIs and SLOs. And as said, none of them have to be crucial, but you can just include them. You will get warnings, you can get complete fails, or you can just add them as informational purposes.
I think that also answers Samar's question. I think you've also answered another question from Samar, which is about, can we have custom SLOs?
Yes, absolutely. So the SLOs, they are not predefined by Keptn. You can have the SLIs. These are, let's say, pre-built, and they are already available inside Keptn, but the SLOs, you would just define them by yourselves. It's the SLO definition is a plain YAML file. We can also take a look at our SLOs here. So this is actually the YAML file that we defined, and it just says this probe success percentage has to be higher than 95% to pass this evaluation. If it does not satisfy this criteria, we are allowed with half of the score because we get a warning if it's still higher than 90%. So this is the complete, all these lines, this is the complete SLO file. And you can just add more and more SLIs and SLOs here and just increase the robustness, let's say, of your quality gate. If you only have 2 SLIs and SLOs that you want to check, it's not a lot, but you can include more and more. We have seen installations with Keptn that check against quite a lot of SLOs because they want to check each and every aspect of a microservice. And that's totally fine. Just for the demo, we decided to just go for some kind of uptime criteria so that we can see when we kill a pod how it will affect our availability metrics. I think we have another question. The question is, I'm thinking it will be great if PMO passes this SLO as a YAML in very early stage of requirement gathering and understanding that if that is a possibility. I'm not sure if I do understand this question correctly, but
I think it's about, I think Deepak is making a comment that we could start setting the SLOs right during the requirement gathering stages of an application or a project, so that we can go ahead and see how we are adhering to it right from the beginning and probably improve our applications along the way. Yeah, I think he said yes. So yeah, that's a great thought. I would probably just recommend you to read up on the philosophy that's being adopted nowadays called chaos first, and it's something that we are trying to help advocate as a cloud native chaos engineering group as well, Deepak. So chaos first is an approach where right from the day one of your application journey, you start with chaos experimentation. And we can use tools like Keptn to do automated delivery and include chaos as part of that. So you have a tab on how your applications are behaving. The SLOs can be recalibrated as you go along, or you can even use the Litmus portal, which is another tool which we will look to integrate with Keptn, which is giving you even more information about how your resiliency scores can be set, weights can be set against experiments. So yeah, so chaos first is what we're calling that approach, what you just mentioned as. I think that's really important. Thanks for bringing that up. There was another interesting question, Jürgen, about serverless chaos, which I think is an altogether new topic. And I think Keptn being an event triggered framework, and we're also working towards experiments, Litmus framework being event triggered, so it should sort of integrate at some point with serverless, though that capability might not be aware today. Do you have any thoughts on this?
I think it's a very valid use case. What might not be, like, our experiment won't be easy to replicate in a serverless world because you can just not kill a pod. But having some downtime or network issues simulating this is very valid. For Keptn, it does not really matter where the application is running. If it's a monolithic application, if it's a microservice application, if it's a serverless application, as long as there is a way to query metrics for this application. So if you're monitoring this with Prometheus or Dynatrace or some other monitoring, and Keptn is able to fetch the data, then we can perfectly do this quality gate evaluation. And if it's possible to inject chaos into serverless applications, that would be the question to Kartik, because I'm not sure if that's possible right now.
Right. I think one of the things that sort of helps us in that aspect is the Litmus experiments run as a one-time job. That sort of fits well within the overall paradigm of serverless, but it depends right now. When you say serverless, if you're doing it on some infra component that Litmus is not able to talk to today, and that's something that we need to build, that capability. For example, you're running up an instance and you're doing something against that, or if it's on Kubernetes, then you already have a way to do it. So it depends upon what type of functions that we are running, but that's definitely an interesting area. And we'd like to hear more about it if you have thoughts around that, Samar.
Cool. Yeah. I just want to take the last couple of minutes. If there are more questions, please also put them in the chat or in the Q&A, and we still try to answer them. I just want to go back to the slides and just highlight how you can actually use this. It's available as of today. So this integration and the demo that we showed you is already available on GitHub. To install the integration, it's basically just one kubectl apply, and you would just install the integration between Litmus and Keptn. Just make sure you first have to install Keptn and you first have to install Litmus, but the integration for those two, it's basically one kubectl apply, and then you will just add the chaos experiment to Keptn. Keptn will add it to its internal Git repository, will manage it from there. In this way, it's also able to pick it up again and execute the chaos. All this information, how to install it, how to run it, how to use it, is in the Litmus service repository in our Keptn sandbox. Keptn sandbox is our organization where new contributions to Keptn go. So it's in a very good company there with a lot of other tool integrations. Let's say it's a little bit like the Chaos Hub, where you will find a lot of chaos experiments, and in the Keptn sandbox you will find a lot of Keptn integrations. It's on github.com/Keptn sandbox. Please take a look. If you think of a new use case, if you want to help us improving it, file an issue there or raise a PR, we are happy to include this. I've already talked about this a little bit in the beginning. What we are thinking about as the next step is actually also to consider the results of the chaos experiment that are already part of Litmus, to consider them and take them into account as part of the evaluation. Right now, we are taking into account the data from an external data provider like Prometheus. And the second step that we also want to achieve is to have Litmus Chaos as the tests for auto-remediation. So not only in shifting left into your CD pipeline, but really having this as a way to test your operational scripts. If something goes wrong in your environment, in your Kubernetes cluster, or in your application running on Kubernetes, how do you usually react on this? Are there any scripts that you would trigger as a human as a counteraction if there is something going wrong? Keptn has this capability. Litmus has the capability to introduce chaos. So we want to bring this together again and have chaos engineering as the actual testing for self-healing or auto-remediation. This is what we're aiming for in the next step. So with this, thank you so much, Kartik, for joining. It was a pleasure to have you here on the webinar. We will also share the slide deck. I think the best approach is I will upload the webinar tomorrow to our YouTube channel. The YouTube channel is on Keptn, or it goes by the name Keptn, and I will link also the presentation there. I can also post it in here really quick, and hopefully you have access and take a look and can take a look. I will just post it in the chat, but I will also attach it to the YouTube video that will go live tomorrow. Yeah, I think there are no more questions. So with this, we will be closing this webinar. Thanks again, Kartik, for joining. Yeah, have fun, everyone, introducing chaos to your applications, and see you soon.
Thanks, Jürgen. Thanks, everyone, for joining today. Have a great day. Thank you. Bye.
Thanks. Bye.